All right, so let's continue. Now that you've given the others a try, here we go. Number 13 says, write the rule for the nth term of a sequence below. Now, we haven't seen sequences in a while, so this is definitely the Unit 7 word wall. Now, the sequence is just an ordered list of numbers, and so we always want to try to find some sort of pattern because we need to know whether it's an arithmetic sequence, an arithmetic sequence, right? There's two ways of saying it, a geometric explicit or a geometric recursive. Now, remember to tell the difference, they never said the word recursive. So if they don't mention the word recursive, then I will not be doing a recursive formula. So let's find out what kind of pattern this has. Now, I do notice that my numbers are getting a little bit bigger. So 5 to 15, well, I can multiply by 3. I could also add by 10. But then to go from 15 to 25, then it looks like the pattern is that we're going to be adding a 10 as we go along. So then if it's addition, then we're going with an arithmetic explicit again. To be recursive, they would usually tell you the word recursive in the question, and they didn't. So if we're doing an arithmetic or arithmetic sequence and it's explicit, notice the two things you need. You need the common difference and you need the very first term. Well, then, this is the common difference. The letter D for common difference would be the 10. They did say that we need the zero term, not the first term. Now, notice, this is where this one got a little bit interesting. This is A1 right here. Your 5 is your A1. What they're asking is, who was your A0 over here, right? Before the 5. Well, think about it. If we were adding 10 going this way, well, in order for you to find your A sub 0, if you're going to go that way, well, then subtract the 10. And then we see that our value for A sub 0 is actually negative 5. So we're ready. When you write the rule, remember, here's what the word wall says. A sub n is equal to dn plus A sub 0. So A sub n is equal to d times n plus A sub 0. But when you're creating a rule, when it says write the rule, you leave the n alone. Don't mess with the n. This has an n. Leave it alone then. The letter D, okay, that's not an n, so I'm going to put the number 10 there where it belongs. And then I write the letter n because you're supposed to leave it alone when you create the rule. And then it says plus, all right, that doesn't have an n. My A sub 0 was negative 5. Oh, if it was a negative 5, then maybe I should erase that plus really quick. And instead, because it is a negative 5, I'll write minus 5. And just like that, we wrote the rule for this explicit arithmetic sequence. Okay? So now, let's look at number 14. Now, number 14 also says, write the rule for the nth term of a sequence below. It didn't say the word recursive. So we're not going to use any of the recursive stuff. I am going to look for a pattern though. So check it out. My numbers are getting smaller. So I might say, oh, subtract the 4. But a 2 minus 4 would not be a fraction. Then that means this has to be geometric. And one of the things that we mentioned about a geometric explicit one is the R. When you're finding your R, the idea is you take, let's say, the second term and divide it by the first term. So we divide them from each other, turn it into a fraction, and this is how we find that R. So here we go. If I want to see what the pattern is here, then look at what it says. We already know it's not arithmetic. If you notice, we're kind of saying, oh, I'm just dividing by 3. Dividing by 3, but it looks weird when we write it like this. So if I use that little formula, it says, take your A2, there's my A1, and I'm going to go 2 over 6. Of course, I'm going to reduce it because I would not leave it like this. And my answer ends up being 1/3. Remember, division by 3 is the same as 1/3, but this is what I'm going to use for my nth rule. Now, let's look at our formula and see what it needs. So looking at this formula very carefully, it says when you do a geometric explicit, again, they didn't say the word recursive, So here's my formula. Let's see if we can make it fit here. All right, so here's my formula. And it says a sub n is equal to a sub 1. Well, we do have our a sub 1. Look at that. That's the 6 right there. It says r, well, we know what r is, to the power of n minus 1. Now remember, you're creating a formula. Anything with an n, you have to leave it alone. So here we go. This has an n. I have to leave it alone. A sub 1, well, that's the 6 right there. That was the first term. So 6, I already know what r is. We just found it here. So I'm going to put it in a parentheses, of course. It just helps to separate it a little bit. There's the 1/3 that we found earlier. And yes, this has an n. Then leave it alone. When you're writing a rule, you do not replace anything for the letter n because we're just writing a rule and nothing else. All right. And then we have number 15. Now this one changed it up a little bit more. They said, we want you to find the 25th term in the sequence. Well, look, we already know this is A1, A2, right? A3, A4. They want to know what number 25 is, way out there. Well, you can keep going if you want until you finally get to that number, or we can create a rule. This is why we were creating rules earlier. So I know there's a question like this on the test. So let's find out what kind of pattern it has. The numbers are getting bigger, but let's see how. 3 plus 6 would be a 9. 9 plus 6 would be a 15. 15 plus 6 would be a 21. And I think we found our pattern. We're adding 6 every single time. And if my pattern is that I'm adding 6, then that makes it an arithmetic sequence. Again, they didn't say the word recursive. This is an arithmetic sequence, and we just found that the letter D is 6. Okay? So they want me to find the 25th term. Well, I'm not ready for that yet. First thing I'm going to do is I'm going to create my rule. Okay? So in looking at this very carefully, remember what the rule said earlier. When you're writing an arithmetic explicit sequence, remember, not recursive, I need the letter D. Okay, we have that. But I needed the 0 term. So remember, that was the one special case again, where I need the term that happened over here, a sub 0. Well, again, if you were adding 6 to go to the right, then I should subtract the 6. So 3 minus 6 would be -3. Now I officially have everything I need for this problem. So here comes my formula that we had earlier. A sub n is equal to dn plus a sub 0. All right, here we go. A sub n is officially d, which is 6. We leave the n alone. And then my a sub 0 was a -3, so -3. There's my rule. Now, how do I use the rule to actually answer what they wanted? Remember, they said, give me a sub 25. Well, here we go. Look, the fact that they said, all right, now you're going to finally use the rule. A sub 25 means my n is officially 25. So anywhere I see an n, see, there's one right here, I'm going to put a 25. -3, and now I just let the calculator take over. Let's see. So 6 times 25, and then I subtract the 3 from it, and there's my answer. 147 is that 25th term. And just like that, there's my answer. All right. Moving right along. Finish up this page here. So these go a little bit faster, right? Find the 8th term of this sequence. All right, let's find out what kind of sequence it is first. Let's look for that pattern. Let's see, this is 10 to 20. So I could add 10, but if I add 10 to the 20, that would not be a 40. Then that must mean one thing. They're multiplying by 2. Let's see, 20 times 2, yep, that's 40. 40 times 2, that's my 8. Now, this isn't a fraction in this case. I'm not dividing, but look, we can still do it that way. We said to find the r, you take your a2 and divide by your a1. And so you see, it's just going to be a 2, not a fraction this time. All right, well, let's create the rule. If I want to find a sub 8, I need a rule. No, they didn't say the word recursive again. All right, so here's my rule one more time. A sub n is equal to a sub 1 r to the power of n minus 1. So a sub n is equal to, all right, I know my a1. We don't have to do work for that. It's right there. It's 10. My r is just a 2 to the power of n minus 1. When you write the rule, leave the n alone. Don't mess with it. Don't plug into it. This is my rule. Now I'm ready. They said, tell me what the 8th term will be. Well, that's why we created a rule so we can use it. So when I use this one very carefully, here we go. A sub 8 is equal to 10. There's the 2, 8 minus 1. And now we're ready for our calculator there. And so when I type this into the calculator, actually, this is what I would type in. Don't multiply the 10 and the 2, of course, because the 2 has a power of 7. So that's what I type into my calculator. Let's see what we get. All right. So it's 10 times 2 to the power of 7. And there you go. 1,280 is the 8th term in this sequence. All right. So there we go. Now, we're going to do the other side too, just to get it out of the way already for ourselves. Just give you a moment to catch up. So remember, when you're creating a sequence, yes, write the rule, leave the letter n by itself, then you can use it right after. Don't plug in that number too soon. Now, when we look at the last page of this final review, 3 more questions. Look at number 21. List the first 5 terms of a recursive formula. All right, here we go. Now we're mentioning the word recursive. But what you need to understand is they already did the work for us. They said, give me the first 5 terms of the list. Okay, 1, 2, 3, 4, 5. And they already told me that f of 1, the very first number in my list. See, f of 1. They already told me that number is 5. So I already have one of my numbers. So I really only need to find 4 of them. Now, here was what we did in class with a question like this. The question was, what's the pattern? Now, if you look carefully, I know it says n minus 1. This stands for previous term. It represents the term from before, which means if this is the term from before, right, the 5 here, then if you notice, there's only one thing they want you to do to it. Look at the 2. There's no plus sign or a minus sign between it. When things are next to each other, they're letting you know that the pattern in this problem, the pattern is multiply by 2. That's what recursive functions are like. They tell you what the pattern is, so you don't really have to plug in. If we already know what the pattern is, multiplication by 2, then look. 5 times 2, 10 times 2, 20 times 2, 40, and times 2, 80. This is the fastest way to work with a recursive formula when they want you to find a list of numbers. In fact, you know what? I'm going to show you really quick because I know this is a weird kind of concept. Oh, sorry, let me give you a moment there to get those numbers in. So look at this one. They said, give me the first 5 terms. 1, 2, 3, 4, 5 terms. Well, they already gave you the first one. 3 is the very first term. And now it's time to look for the pattern. So this is what I was trying to get at. If you look at this right here, this is what represents that 3. It's the previous term. And if you look at what's left over, you now found the pattern. Look, all they want you to do, the pattern is you're going to add 5. That's your pattern. Add 5. So all you're going to do is add 5 and add 5 and add 5, and that's how you're going to be able to create that list. Now, I'm going to go back to the we do. I know I jumped ahead and we did something that you were supposed to work on, but I just needed you to understand how these work for recursive formulas. So that brings us to the very last two questions. Okay, I'm going to go back to number 22 here. Now they finally want me to write a recursive formula for this sequence. Well, let's see what kind it is first. Remember, it's either arithmetic or geometric. All right, they're getting bigger. But 3, let's see, if I add 9, that's 12. But 12 plus 9, there's no way that's 48. Then they must be multiplying by 4. Look at that, 3 times 4. 12 times 4. So it has to be multiplication. All right, so we're ready here. We know that we're going to be multiplying, so this is geometric. And because we're multiplying, we actually already know that the R is going to be a 4. Look at that. That's my R because it's multiplication, not division. So it's not a fraction. All right, let's finish this out. It says, tell me what the first term is. Well, the first term is right here. First term is 3, so we put a 3 there. All right, part of it is done. Now I just need a formula, so let's get our word wall going. Now remember, there's this recursive, but that's arithmetic. There's no D. This is the recursive for geometric. And so if I look at that formula there, it says A sub n is equal to R times A sub n minus 1. Okay. Well, if you notice, we said anything with an n, you have to leave it alone. So then the only thing I'm actually going to plug in is that 4. So my formula, A sub n, is equal to 4 times A sub n minus 1. Now, here's the issue. This says F of n, not A sub n. So it's going to be a quick fix. Remember how in these problems over here, they put F of n minus 1, F of n minus 1 on these two? Then I'm going to bring that into this problem. F of n minus 1. So there's that n minus 1 that we saw here. But what was the pattern? Multiplication by 4. So just like the one right above it, I'm going to put a 4 right here, and there's my answer. Recursive formula, some of the easier ones to write down, because basically you're just saying, take the previous term, and then tell me what the pattern was. If it's multiplication, you put it in front. If it had been adding or subtracting, I would have said plus or minus and put that in the back. Which brings us to the last problem of the day and of the semester. Find the sum of the series. Now keep in mind, this is what you start to plug in. Start the plug-in. This is what you end with. So they want me to find the sum. All right, well, I'm going to plug in a 2 first. So when n is equal to 2, I go 3 times 2 plus 6. See, all I'm doing is plugging in right here. Well, that's 6 plus 6, so that's 12, right? I got my first number on the list, 12. But remember, it is a sum. And when you're doing a sum, you're going to be adding. All right, but I'm not done. That's where I start, so I go in order. I'm going to plug in a 3 now. So 3 times 3 is 9, plus 6 is 15. All right, so I'm going to put a 15 here. But I know I'm not done because I'm supposed to stop after I plug in a 5. Well, I'm not there yet. Remember, I'm basically going all the way to 5 is what they told us to do. All right, here we go. 3 times 4 plus 6. 3 times 5 plus 6. And if you notice the pattern already, you could probably fill this out even faster. We do have one more there. So 3 times 4 is 12, plus 6 is 18. See, they're just going up by 3. So if I'm just going up by 3, you could do the math here or just say 21 at that point. But remember, we are not officially done. They said a sum. All right, get that calculator going. All you have to do now is just add these up. So when I add on my calculator, the 12 plus 15 plus 18 plus 21. Look at that. There's the addition of all of them. 66 is my answer. That is the sum. So all you have to do is create the list, but at the end, you make sure that you add everything up. All right, with that said, you have a few problems that you should be looking at. Of course, you should be working on number 17 through 20 on the other side and 24 through 25 on this page. All right, remember when you're done, double check your answers. Make sure you got this down because this is going to be on the final. And so let's get ready. Remember the last day to submit any of these final review homeworks on big ideas, because yes, you have a big ideas homework assignment tonight, is Monday. Monday is a cutoff, but if I were you, I would try to get everything done by tonight. That way you don't have to worry about it over the long weekend. With that said, have a wonderful day, everybody, and I'll see you for the final.